So the figures that they show in section 710, it's kind of clever here because what they've done is they've taken, this is a picture of a steel ball, and they've just taken and laid the frames side by side. So the effect is to create a position versus time graph. On this axis here, on the y-axis, we have the position of the ball, and since we have these frames advancing in time, we essentially have a time along this axis. And so with this steel ball, what we see is this nice parabolic arc, and from this we know that this thing is continuing to accelerate. In other words, there's a net downward force on it. But if we look at the case of the coffee filter here, you can see that right up here we have a little bit of a curve to the graph. So there is a little bit of a net force right up here, but once we get down into this region, our position versus time graph essentially becomes a straight line. In other words, constant velocity. So that's telling us that the net force, once this thing has sped up a little bit, is essentially zero. There's no net force on it. And so since this thing has gravitational force on it, it has to be the air drag that's pushing up. And so in this region here where it's moving at constant velocity, mg down, the drag force has to be at the same magnitude in the opposite direction. Now, the fact that we're seeing this when it's moving slow, that the net force isn't quite yet zero, that's telling us that this drag force has to depend on velocity. And just based on our everyday experience, we know that it depends on a number of factors. It depends on how fast it's moving, obviously. It also depends on how big it is. What the cross-sectional area is. And so one thing for you to really pay attention to is what factors affect the drag force. You should also make sure that you're very familiar with what exactly terminal speed is. This is also sometimes called terminal velocity. What are the conditions for terminals, for an object reaching terminal speed? And then finally, one question to really ask yourself is, what do friction and air resistance have in common? These are both appearing in the same section, so there must be some relation. What is the relationship between those two? And if you can answer these three questions, you'll be in pretty good shape.